Here we are with our Introduction to Java for FRC Robotics, session 7, November 29th. And time is moving along very quickly. Our outline for this evening, there are 3 simple items on the list. Some example strategies for our co-operation. And next week during the session, we'll have our little co-operation run, and we have several teams signed up already. And we're looking forward to, well, everyone is welcome to sign up for the next week, right up until noon on the competition day. And it won't take you long to create a method to go in the co-operation. It was designed to be very easy to access, but completely open-ended. And so we'll discuss a few of the possible strategies you may use in the co-operation tonight. We'll talk a little bit more about the FRC robot simulator and make a little bit more progress from last week, as last week the robot was only going back and forward, backward and forward. And there's a simple reason for that. There's a default setting on the robot that requires 2 game controllers. We'll take a look at that. And our actual scheduled topic for this evening is connecting hardware and software. And we'll have a few examples of how we get into connecting hardware and software and how it might be integrated into your programs. Please feel free to ask questions at any time. I'll periodically look at the chat, but if you have a question, you can feel free to put that in the chat or even to speak up. And there we go. Our schedule again from October to February, we're following fairly closely, moving towards intermediate activities here as we start coding open-ended methods for doing autonomous work in Java. Well, that's getting towards intermediate, even though we may do so with some easy to access code. And hopefully we'll have a few examples about that this evening. And also looking forward to January when we do some more advanced topics. Last time we discussed, well, one topic was how to break your code in your VS Code configuration. There's a sort of an inadvertent reconfiguration of the VS Code that I did 2 weeks ago. And then we discussed how I figured out how to fix that. And that's a good example. These things happen all the time when you're programming and when you're using computers. When you hit a key you didn't mean to hit and you didn't know you did that, it can have unintended consequences. We discussed Git integration, our basic timed robot. We did some sample code. And we did an update on our co-operation game, the Gracious Professionalism Co-operation game, GPCG. And we did some troubleshooting of code and questions and answers. All right, so let's discuss a few sample strategies for our FRC coding co-operation. The first of these is a switch statement for round-based strategy. To demonstrate this, first I'm going to go to the game manual, which has been updated. And I'll just note a few variables you have access to. And I actually updated the game manual further to feedback received from our community. So several people have been in communication about the game, and some of their contributions have resulted in a few more features being added, as I thought that was a very fun thing to do. It would allow for a few more strategies to be employed. All right, so let's go to our game manual. I just may have to find it here. Just give me a moment. Here it is. There is a question here about sessions on the 20th and 27th of December. I do have a session on the 20th, more of a mentor session, not a coding session. We'll have some discussion and preparation for the upcoming launch of the FRC season. At the moment, I don't have anything planned for the 27th. If there are some requests, we might be able to schedule something at that time. That's usually a time when people are out and about during the holiday season. But I'm not going all that far. And maybe if there are some people who would like to get together on the 27th, I'll be very happy to make some scheduled plans and announce them. You can just let me know, email me, or text me. Is there a sample piece of code I can mess around with for the co-opertition? Now, I will also paste in here a few things for the co-opertition. First of all, the game code has been released. The thing is, you may have to install it, and there are a few community members who have successfully installed it. It does take a little bit of work, and if you would like to install it on your computer, I can offer some advice. And you'll have to download JavaFX and configure a few folders and files to get that working. Even so, you don't need the whole piece of code or code base to start playing around. For example, I'll be very glad to give you some feedback about your script if you send me in the script that you have. I'm going to make a sample script right now, and you may take a look at that as a sample piece of code to play around with. So hopefully that will answer that question. Okay, so let's go to our co-opertition game manual. Our co-opertition purpose is to introduce the FRC coders to Java through a co-opertition format, as that's somewhat motivating. And it is also designed to build on the first core values in being named the graciously professional co-opertition game. And it is hoped that we'll create such a environment in our collaboration with other members of the community to come up with our game strategy and code. The format is to play the limited market game with autonomous methods coded in Java, and we've already played that, and I'd be willing to play that again. If anyone needs to see the game played again, you can let me know. Dates and times: Monday, December 6th at noon is the time to receive the registration and also your code, and you'll see that. The registration is here in the document. And just for your reference, I will copy the link here and put it in the chat. Take a look at the chat here. Okay, so there's the document itself, and you may take a look at that. And you may register through that link. There we are. The scenario, of course, is 6 FRC teams are planning to sell team sweaters to raise funds for the robotics season. And captivated by the impact of first, a population of 1 million people decides to support each of the teams by purchasing one sweater each month. So that is somewhat of a fictitious scenario, except that there is indeed quite an impact of first. And that's why I now work at First. It really transformed my career, and I saw the benefits to my students were immense. The teams, all they have to do is set a price for their sweater greater than 0 and less than 100 each round. Sounds simple, but you have to take into account the rest of the players and what they're doing. And that's where the autonomous part comes in. You can respond to the market, analyze how much profit each of the other teams made based on their price, and come up with a strategy for the next month to optimize your profit. So it's quite low-ended in that you can just choose any number, but you can also employ as much mathematical and statistical analysis as you like to come up with a better approach. So the terms that come in the game, the number of customers, here is a term in the game, and it ends up coming out to just under 1 million each round because of rounding off. But approximately 1 million people each round will purchase a sweater. And that depends on the price, how many will purchase each team's sweater. All the keywords for the game have been italicized here. Your expenses are unknown, and you will see them at the end of each round, and your computer will have access to them, and we'll see how you can get that into your Java method. And each round is kept track of by the round variable. So it starts at 1 and ends at 5. Okay. We'll just maybe correct that. I guess Google doesn't like that. I'll just say advance. I was thinking actively advancing them, but anyway, now Google's happier. We'll advance the teams to the next round of fundraising, 2 out of the 6 teams. So depending on how many people sign up, we'll have several rounds. Okay, and the game will be played live. And those were the 2 times before. I'm still willing to play the game if anyone would like to see it played. And the actual custom coded methods need to be sent by email no earlier than Friday, December 2nd, and no later than Monday, December 6th. And the reason for this is it would be a pity to lose your submitted method in the email. And so I've restricted it to those days so that there's a lower chance of missing someone's method being sent by email. Okay, and there's the email to which you may send your code. Java method details. Here's where we get into our Java method, and that is the enclosing code for the method. And it's going to take in a game details object for which there are certain variables that you have access to, and that will return some floating point number thereafter. And this is what we're going to develop this evening, some kind of approach to a strategy. Okay, here are the basic variables to which your method will have access. The company names, even though that has nothing to do with the prices, just because you can access them. And maybe you could do some kind of superstitious letter-based prognostication on the names. It's all up to you. The prices is a far more useful variable, and it's available, and you may determine each team's price as with the number of customers, the revenue, expenses, profits, and total. In the first round, when you make your first price choice, all of these other variables here will be 0. So you have to blindly select a starting price, and this may be done randomly or according to your favorite number between 0 and 100, or whatever you like to do. It could be based on some strange combination of the company names, for all we know. And another variable that was added through interaction with our community is the variable round, as I had not originally conceived this as a valid variable, but now you can make a strategy that varies each round. And we'll show you how this evening. Okay, and here are some examples of how you get access to the various parts of the or the various data within your variable. And I believe we're going to have to do a slight adjustment here. It's going to be in the game details object. So I'm going to make an adjustment here.
Is that because the game details will reset each round?
And no, because all of the data is enclosed within a current game details object, whereas in my original code, it wasn't. So the way it's being sent out to the strategy method is enclosed in a current game details object. So that was a slight oversight there, and hopefully you will make note of this in your code. Okay, we'll do some examples here to see how we can get this working. So let's go over to VS Code and open up the game. Here is the game, and let's just take a look at the game details object. This is a framework for storing all of this here. There's also something called my index. I haven't really emphasized that at the moment, but you can actually determine out of the 6 players, what is your index? So you could do something based on your own profit, for example. So this my index variable is also available. I'll make that update and show that to you. There are all the methods for getting and setting the various values in your game details object. And this is just a blank framework that's employed by the game and sent to the strategy autonomous play section of the program. Okay, so here's the strategy method. And what I'm going to do here is rename this one for each of the competitors in each of the rounds. So for example, there is a format for naming your strategy ABCD. So there's strategy 1, we'll say strategy 0771. There's the strategy for team 771 and strategy 1, 2, 3, 4. There's strategy for team 1, 2, 3, 4. And that's how we're going to name your methods here. So far, I've only got strategy 1, which is a very simple method. It has the minimum and the maximum, and it creates a new random number and returns that random number. The number is between 0 and 100, not inclusive of the endpoints. So it'll send out a number between those numbers. So how are we going to make our own strategy? Let's try that.
William, is the minimum 0 or is the minimum greater than 0? Because that keeps changing.
It's greater than 0 and it's less than 100.
Okay, thank you.
And yeah, that's very important to note, as it will cause the program to crash, as we saw last time. When I entered 100 as the price, I had forgotten the endpoint issue, as I had considered taking it in or out. Anyway, it crashed the program. So it is very good for you to test it or to make sure that it's only going to give numbers greater than 0 or less than 100. Okay, and we're going to take in a game details variable. You don't have to call it current game details. You could just call it G if you want to have the code be a little shorter. And the first thing that we might do is make a strategy based on the round. So you see I'm using a get method, and get round will get the current round. And my Python programming instincts have served me poorly here. So I've done something with this R. What should I do to the R to make this a valid Java command?
I like what type it is.
Yes.
Like if it's like an integer, if it is a string, if it is a float, so on and so forth.
Indeed. So that was it. Okay, and so I put down the int there as it is an integer R. And now let's do a Java command for switch. This is going to choose between multiple possibilities for R. All right, so here's a switch statement, and it has 6 cases in there, and we can do very simple cases. We can do this, return 35.40 floating point value. There we are. I just returned a floating point value of 35.40 for my first round. Then I can make something based on my profit. So I can do this. If current game details dot
Get profit.
Get profit. There we are. Thank you. And let's just say for the 4th player is greater than 0. If that player made some money, then we're going to set the price to that player's price from last time. and it's probably get price. Is that it? No.
Why is there a red line under get profit?
It's probably because it's not available. So let's just double check our API here, see how we're going to access it.
Possibly set it to like private or
Public, get customers, get prices, get revenues, get profit. Ah, that's it. Okay. It's going to return the profit as a list here. So let's just double check that. So we'll have two steps in here. That's interesting. It doesn't let me define that. In the rest of the game, it did. Oh, sorry, it's capital. Okay, so now I'm defining P as an array list, and now there we are. So here's how the current game details works. The get profit is going to return an entire list of 6 profits from last turn. And here's the 4th one. And that's actually the 5th one. So player 5 has an index of 4, and we're just checking if that player was profitable last turn. And if so, we're going to return some kind of price, like 50. Or we could return that player's price from the last time. Or we'll call this last prices. Okay, so there's our new array list float. These are the prices from last time. And we're going to return the 4th one. Or sorry, the 5th one. And we have to use a getter. There we go. So it does take a little while to get accustomed to the getting and setting and the syntax here, but hopefully a few of the examples here will help us to practice that. And I'll put up some of this code on a repository and send a link for it. So let's try a few more examples just to see how to work with things. What if we wanted to find the average? What is the average of all the prices? So first of all, we're going to have to use the total. And it's going to be a floating point number, and we'll set it to 0. And well, we know that there are 6 players. So we can just say int num players equals 6. And we're going to use a loop to add up all the prices. So first of all, we can take this prices from last time. Interestingly, we could repeat this code, but since we're using it in multiple parts of our switch statement, we can just use it up here and just get the prices up here, last prices. Okay, so what's the average of all the prices? We're going to do this. Use a loop, and we start with I equals 0. That's the index equals 0, and index smaller than number of players, and do the increment I plus plus. And we'll do this. And total plus equals last prices dot get I. So we're getting the each price in the last prices list. So I've imported it at the top of the method here. Crunch down the code a little so we can see it on the same page.
There is an error on like at the top, at the very top of the method. Or like strategy 1, 2.
It must return. So we haven't done the return yet. So I've added now to the total all 6 times, hopefully. And now the average is going to be another floating point number. And that will be the total divided by the number of players. So that might be a nice one to know what the average price is. And then based on that, we could return something having to do with the average. So whatever the average was, add 5, for example. Now, why would I have to be careful with this one? What could happen? If I leave it like this, it's actually not going to work every time. And most of the time it will work, but it won't work every time.
Well, you might end up with over 100.
Yes,
Yeah,
there
you might
is a
end up with over
possibility.
100.
And I was really happy to see many of you, or several of you in our conversations were thinking along those lines. So if I just do this, it might be out of bounds.
Do you have a way to check if player's price is over 100?
So yes,
game?
in the like in the final part there, we're going to do a validate. I have a validate routine, and it will just set it to 100 if it's over 100, and it'll set it to 0, or sorry, just below 100 if it's above that. It'll set it within bounds, basically.
Yeah.
You will do that. We don't have to do that in our code.
I think I'm going to do that, but I would advise doing that anyway. You should be careful with your code. So that will ensure that no one's code is going to break the tournament, but it would be good for you to do that just in case your code is not working as you would like. Okay, so we could do something to keep this in bounds. If average plus 5 is smaller than 100 and and if it's bigger than 0, for example. That's getting a little bit awkward. So I could do this, something like final price. And we'll just say final price is equal to average plus 5, floating point. And we'll have to call that a float. Okay, now we have that. And so if everything is all right, we're going to return the final price. And if not, we could do something else. For example, I could just say else. Just 50, for example. I could do whatever I like, I suppose.
In the various switch scenarios, there's always a default. How does that work?
So if none of these works, then we could do some kind of default thing like return 12.34 or 12.23. Great. We'll just have now, if we're playing the game and if all is going well, it should never get there because there are only 5 possibilities, round 1, 2, 3, 4, or 5.
I also noticed in some of the switch code, there's a break. What's the purpose of the break?
And we do need to put breaks when we finally do this, I believe. Is that it? Unreachable code. Maybe. Oh yeah, because this is just returning, it'll never reach there anyway. I suppose in a regular program, it's just going to keep going, but breaks are needed so that you don't go through the rest of these cases, I suppose. I don't think you need them here because we're returning. If it gets into case 1, it's just going to return. And the same with all of these.
That's cool. So William, would it be a much more convoluted process to do the same thing with if then else loops
with some
instead of using switches? That's what I was
how do you mean loops? Like, for example,
like
from 1 to 5?
If it's round 1, we do this. If it's round, else do this.
Yeah, exactly. You could, a switch statement is just a big, complicated set of if statements, more or less. It's equivalent to them if you set them up carefully. So you can do the whole thing using if statements. You can just say if round is equal to 1, for example, game details dot round. Yeah, so there's R, it's already been declared there. That variable R is now your round. If R is equal to 1, then we do this. And if R is equal to 2, then we do that. So that's also possible.
And then you would do else if, else if, else if.
Yeah, it can be else if, or it can be completely separate. Just carefully follow the logic. Yeah, you can say if round is 1, and then we do this, else if round is 2, do this, else if round is 3, and finally else, you can do this. Now, I'm always wondering about computer programming style and level of precision. We are banking on the values coming in to be 1, 2, 3, 4, or 5 for the round. Maybe just in case you can have some code in case it breaks. So the final else will be, if nothing else, just return 50 because you don't know what else to do. But if the program is designed properly, then it should have only those 5 values. So it depends on the purpose of your learning computer science. For the purpose of this game, those 5 values should be fine. I think for the purpose of professionally developed code, they have alternate cases just in case something else is happening or in case someone else uses this code outside of its original purpose.
So if the default in terms of a robot on the field could be like, if your auto can't shoot and your auto can't line up its target, at the very least, get off the line.
Yeah, exactly. And they actually have some switch statements that are used to determine the behavior in auto. And that's what we used to do. We used to have the base case available, but we would still select it in our driver station. So let's say your robot was only going to be able to do auto if it's on the left-hand side. Well, if it's in the middle or the right-hand side, we can just cross the line, for example.
The robot couldn't determine that for itself. You had to tell it upfront.
Yeah.
in the setting.
I believe, if I'm recalling correctly, we selected that using our driver station.
I think you talked about that last week.
And sometimes it's hard to comment not having the robot right in front of you, but that's how I recall it happening. There we go. And I just returned 60 and I returned 70. There are lots of different things that you may do, but what I will do is try to copy and paste this code, or what I'll actually do is just update this code on the GitHub. And that way it'll be available right away. You can go down here, add this, save all and commit, and push it up to the internet. And now it should be available, and I'll take the URL and paste it in the chat.
I have a question.
And, oh, pardon?
How would you, like, when you're committing, like, how can you put like different commit messages, like for like each file that you upload?
Oh, I'll show that in a moment here. I'm just going to verify that it just, 30 seconds ago, add round to game details. I guess that was my message to last time. I forgot to change that message. And I'm just going to check the autonomous play, and there is a example switch statement in there. Okay, so now how do we update that message? Let's go back to the VS Code and do a little bit more work. Let's say that we wanted to make this 90, for example. Now we've changed one of the files. And I could just do this. I'm going to cancel that. First of all, there's my message. I'm going to say changed autonomous case 4. There, I just changed autoplay case 4 and save all and commit. And now I'll push that to the internet. When I go back to the internet now,
It says there are no changes to commit. Why is that?
I'm not sure. Did I not change enough of the, add round to game details? It didn't let me do that. Let's try that again. Maybe I have to save it. Didn't think I have to save it. Yes, I did have to save it. So now I changed autoplay to case 4 using that message. So I suppose you have to remember to save so that we'll remember to do that. Interestingly, I think it's been auto saving because I didn't particularly save it. It may be just auto saving every so often. Okay, I'll just take a look in the chat. There are several comments in the chat here. And
Did you want to post the link to that?
oh yes, thank you. I'll do that.
You could tell I'm eager for it.
Excellent, I'm very glad. So we go.
I really tried to keep up in VS Code, but my screen's too small. I only have one.
Oh no, yeah, sometimes the computer doesn't help there. But anyway, there is the code, and please feel free, everyone, to continue corresponding my email in the meantime.
We want the autonomous one. Is that the one you just worked on?
Yes, autonomous
Or the
play.
game details, or both?
So let's see here. I changed mostly the autonomous play one. And there were a few questions here in the chat. Let's take a look. So,
How'd you download JavaFX?
so how do you download it?
Yeah.
Okay, I'll take a look at that in a moment. I'm just going to, okay. Some comments about the economy. So now the JavaFX. I went to JavaFX and it should be under documentation, getting started. And down here, it does mention you need a Java development kit for at least level 11. I believe that should work with the FRC. I was reading elsewhere on the internet that it was up to 17. So you can probably proceed as if you have Java installed. And then let's see where we download. Oh, install Java. Okay, there it is. So getting started with JavaFX and install the JavaFX software development kit. And then there are some instructions for Windows. And I'm not sure about Mac. Oh, Linux and Mac. Okay. So basically on this site, I'm not sure why this is looking different than I remember it looking, but I remember doing all of this and it somehow worked on my machine.
So do we need
There
to
we
install
go.
it through the command line?
This is it. Oh, sorry, I missed what you had said.
Do we need to install it through the command line? Like, do we need to like put in like a few like it told us to like put like a few commands on the command line.
I had thought that for a moment. However, I did find the page here where you actually download it. Now I remember. So going back to where I was, right in here. Yeah, use the JavaFX software development kit right here. And that's what I clicked on and it brought me to this page. And then there are the binaries for Linux, Mac, and Windows. And usually you're probably going to have an x64 system and you want the SDK. So for example, if I had a Windows machine, I would probably download this one. If I had Mac, I would probably do this one. And the one I did download is the first one there, the SDK for Linux. You can make some choices up here with the architecture and the type. It's the software development kit you want, and also the different versions. But the one that I used was 1701 to develop that game. So hopefully that will get you started. I have been working with a few of the community members to do the installs, and please feel free to contact more because it's hard to provide all of the possible things that could be a challenge in one session because everyone's computer is a little different. So going back to the chat here. So I'm not sure about this. I'm trying to view all my example projects, but it's only showing the first one in the file list. Might you clarify that one, Liam? Oh, okay. Trying to sync a project with a Git repository. Oh, you solved it. Okay, that's good. It's good to hear. Sometimes with computers, you just try a few more times. Even when you saw me leafing through the site there, I was scanning for a place to do the downloads. It wasn't readily showing where to download there. I was expecting it at the top of the screen, but after a little bit of trial and error, I seem to have found it. It was kind of hiding in the middle of this paragraph. Okay, so we are going back down to.
He did not actually solve it.
Oh, he did not solve it. Okay, we'll get to that one.
He thought he did.
Oh, no. Yes, that can be a challenge as well. So our method can be in any file name. It doesn't matter what we name the method's file, because I'm just going to copy and paste that method into the program. So you could name it in a text file or any file name you really like, some kind of text file. So I don't think it would be quite, well, you could name it as a .java file, but generally Java files contain a class, and this one's just going to be a method. So a text file should suffice. Okay, so you've tried to sync the project with a Git repository. It's just getting an error message. So that's something we may be able to troubleshoot together. And with your permission, Liam, maybe we could do a little troubleshooting and see, oh, whoops. Just getting an error. This is a new problem. Solve the old one. Okay, and I'm wondering, Liam, what is the error message that you're getting? We can let Liam type that in. Now I'm going to this one. What about assert false in default if you don't think the code path is taken there unless there's a bug? Oh, that sounds like a very good idea. Let's see. I've actually not used the assert false. I'm wondering, Andrew, might you just let us know a little bit about the use of this assert false in coding in Java? And meanwhile, I'm just going to try it here. It likes it anyway. Java assert. And what does it do? Oh, I guess it's not meant to ever be used if you have to assert it. So I'm sure we could read through all of this material here and we could discuss the use of the assert. It appears to be something that it wasn't meant to happen, so we're asserting that. And maybe Andrew might share a little bit about that.
That article is 11 years old.
11 years old, indeed. That is an issue. Although the Java language hasn't changed all that much. If it were a JavaFX article, I would definitely not reference it. But since it's the Java language itself, assert functions haven't changed all that much, is my suspicion.
It's usually like programming languages like evolve like quite a bit. So I just thought that 11 years could be a bit of a problem.
I would think some languages have evolved significantly over that time. For example, Python went from 2 to 3 at some point. They tried really hard to support 2 and 3 for a long time. Eventually, they switched to 3, and so now all your print statements must have round brackets to enclose the content of the print statements. But Java, for some reason, I just have this idea that the basic assert statement hasn't changed, even though I've not used that statement. If I have, I don't remember it. If you think something is true, if you assert false, you're kind of saying, I never expect the program to be here. Oh, thank you, Andrew. So that's really helpful. And we will see how that works in practice. I may try that out and try to put a 101 there and see if it ever gets there. Or actually trying to put something outside of 1, 2, 3, 4, or 5 and see if it gives us some kind of message. Great. So that was a little bit about using the programming sort of object, which is the game details object. And we use current game details.getRound or current game details.getPrices. If we get the round, we're getting an integer. If we get the prices, this returns an array list. And then we have access to all of the prices. Oops. Okay, so if you're playing the game, the my index variable may come in very handy, as it is a number between 0 and 5, and it's your index. So that's what you priced it last time. And that could also be used for checking your profit, for example. So what is my profit? We'll do this float. And actually, I'm going to call that in, because if I call it I, it could be confusing because we're using I in the loop down there. Just to keep that okay. And maybe in is not so good. My index. My profit. So I'm going to need to get the profit out of the current game details and then use the well, here's the pattern we'll do. Last profits. The last profits is a variable I'm going to have to set right here. And I'll use this instead of last prices. I'm going to say last profits. So what is this saying here? Here's an array list of floating point values, the last profits. It's going to be from the current game details dot get profits or get profit. So that's an array list of the profits from the last round. And now my profit is based on my index. So right here, I declared my index to be a number between 0 and 5. I don't need to know what it is. I can just use this line to set it. And my profit from last round is going to be based on last profits, the array of all the profits, but the my index variable gets your particular profit from the array of last profits of all the players. That would be a good thing to update. So my players index, and here. There, that's good, because you will want to know if you were profitable, so you can find out what your profit was and work from there. That's something we can save and then update my index.
You have an error on the strategy.
Oh, thank you. So where is that here? Is it that one? It may be the case. Just trying to figure out where it is. I think this is because, oh, it's not returning a float, is it? It should be because it's not used. Ah, maybe because we asserted false, it doesn't like us anymore. Yes, that was it. Because I took the return, then it's not returning something, and then there's an error. So I have to return something. So I just set it back to returning 50. So that's something we can look into next time. Now that's not an error, and this is expected. It's because it's not used, and I could actually make it used, because when I copy and paste someone's strategy in there, I can just do this. 1, 2, 3, 4. And that's how I'm going to connect your methods into the game, because now I'm calling the strategy 1, 2, 3, 4 method, which is this one, and now there's no longer an error there. Okay, my profit is it's a slight error, it's just not used. So it's warning us we are not using my profit. I did hear someone say something. I'm not quite sure I heard.
I just said you forgot the underscore.
Ah, okay. Oh, thank you. Okay, so I'm setting the message here, update my index and my profit, just double save again, stage those changes and push them to the internet. and double check that they made it. We'll go back here to the, oops, I have to get the zoom out of there. Autonomous play updated my index and my profit. There we are. So hopefully this example here will allow you to create your own strategy. And I'd be happy to continue working with you by email afterwards.
Can you do it while you're there? Can you
Sure.
pause for a second and just explain the files that are on the Git for the Gracious Professionalism competition? Like,
Sure.
we know autonomous play does. That's how you're going to insert us into the game. What do the rest do?
Okay, so we start with our app file. This is the main file here, and this is going to launch a graphical user interface program. And to do that, it's going to access the fxml file, which is a style sheet storing a connection between some of the variables and the look and feel of the game. And that's in the fxml file there. So we can look at the fxml file, and it's just a logical organization of, well, there's the menu. And this is actually just a standard menu. I haven't even edited it. I should probably take a lot of those out because they're not actually being used. So I just copied and pasted a standard menu from the graphical user interface composing program. Down here is the stuff that we're more familiar with, the labels and the table and so on that's used in the program. It looks very complicated, but I didn't do any of that really. I just did some dragging and dropping and exported an XML file. Later, I went into the file, and where I needed a variable name, then I put it in there. So let's see where there's some variable names being used. FXID, so TBL companies, that's the table, and there's its variable. And then customers column, revenue column, each one of them has an ID. Okay, so the overall app, all it does is look into its resources and starts a graphical user interface program and uses that file as the template to start the graphical user interface. Now, this is a common pattern in web programming and graphical programming, having models, views, and controllers. The app, it gives its control over to the controller. This is sort of like the traffic cop for the program. In here, it's going to take information from the game and then display it in the display. So here, it's importing all of the fxml references for variables, and we'll be able to write values to those variables and have them show up graphically. So now in the controller here, it's looking for when you submit a button. When you click a button, it's going to do this. It's going to check the current prices and current company names because those are the only ones that you can change on the graphical user interface and put them into variables in the game. And then we're going to set within the game's variable, we're going to set the name for all the current names that you entered. And then it's going to send the current prices into the game. And where do we define the game? We just make a model of the game. Okay, so this controller does that. And then when it sets up, here's the initial setup. And there's one more thing that happens. Once you've edited something, it updates the values in the graphical user interface. So there's only one real big function happening. This button click operates the game here. And the rest is just setting up everything when the game starts. So it's calling the game in the model. We're calling it game. It's a model of the game. Here's all the information in the game, what round it is, what are the average of the prices. It calculates the revenues, expenses, and profits, and all of that.
What is the difficulty?
Oh, pardon?
What does the difficulty variable do?
Oh, the difficulty variable? When I used to play this with my university students, we'd start out with it at 1, But when you put it at 10, then it's very difficult to make a profit. So
Oh,
it's a basic economic indicator. When it's 1, it's easy to make a profit. When it's higher, it's much harder.
can we try playing it on 10?
Yes, we can.
I did badly enough on 1. No, thank you.
Oh no, so whoever loses less than 10 to the $20 would probably be the winner. Who knows? We'll have to see. So that's what the difficulty is.
What's tax rate? We didn't have any taxes as far as I saw in the.
I also haven't implemented that. I think that was in the original program. I directly copied this off of a spreadsheet, and I originally intended to have a tax rate and some other things in there, but we had so much fun with the original version of the game. I never got around to doing the rest of the game because it was too much fun when we played it like this. And so there are various variables in here, and you can see there is room for the game to expand over time by taking advantage of the difficulty and the tax rate and so on and so on. We add the company names default in here. That's the default names that show up, and they're the default prices and amounts that show up when we initiate the game. And this is actually the constructor for the game. It makes the original default values. And here is what happens when you click a button. It initiates the execution of this turn method, and then it goes through a bunch of steps here. We capture the current game state and send it to autoplay. So here, all the data, that's all the data that we send to the autoplay, and there's your my index variable. It also gets sent in there. So there's all the, it's kind of like this is packaging and sending out some data for your auto to use. Going down in here, oh, validate. This is where we're making sure it's less than 100 and greater than 0. And actually that should be an equal sign out of there. We will take a look at that little detail later. Okay, and this is in short, that's what the model is doing. It's keeping track of the game data and sending it back and forth to various places within the game. Game details, we already saw that earlier. There's where we package up some game details for your autoplay to use. And then finally, the autoplay here. The autoplay, it has this strategy method, which, depending on which player it is of the first 5 or the 5 or 6 players rather, it's going to select one of the strategy methods. So we're just going to type in a number here for each of the players and have a whole set of methods copied and pasted right here. That's the design of the game, and I'm sure it could have been designed better. It was designed based on some, like 2 or 3 different programs that were examples on the internet, and they were just adapted to make use of this game's functionality. Hopefully that's all of the things about the game. Oh yeah, this PNG file is just the logo, and it's read from the app.
And that's used in the graphical interface.
Yeah.
Well, that really helps. It helps to see how the files work together.
Yeah, it was really informative to me. I've never tried something of this complexity, and it was a really great sort of learning experience for me, and be welcome or very happy for feedback about that as well, because I don't come from a professional background of programming, but definitely from a high school level of programming. So we've gone to do all kinds of different projects and found them very interesting. So there's the game. There were a few other things I wanted to share this evening, and very happy to answer additional questions. Let me just check on the chat. Ah, good. The code in there just kind of works. Well, it kind of works now. It kind of didn't work as it was being developed, and there were numerous pitfalls along the way. And many examples had to be tried, and then numerous references to Stack Overflow had to be done to get the various pieces working.
How does the so when you're getting information, where is it like temporarily stored until you return it or until you do something with it?
So when you're getting information for your autonomous routine?
Yes.
Okay, so let's trace it through the app. The controller is going to watch for someone to press the button. When we press the button, it's going to send the current prices. That's the most important thing. It's going to send the current prices to the game. And so now the game is stored in this app model, GPCG model. And when we import the term, we package up a game details object, and there's all the prices, names, customers, the round, and my index. And now, here it is. You're going to add to the prices, we're going to add the autoplay.strategy, and there's the current player's index, and there's the current game details. So we send the current player's index, and we send the current game details object into autoplay, and it gets back the new price for each of those players. That happens instantly, but it's executed 6 times. All right, so we send or call to the strategy, which is in here in the autonomous play. And the strategy now is going to further delegate to one of the 6 strategies, depending on which player it is. And then it is going to return number, which is in turn returned back to the game, and it's sent back to the model, which sends it back to the graphical user interface. There's several steps there. So a whole cascade of events happens. We get the updated prices on the screen, and we see what happens. So hopefully that answers the question. I'm not sure if it did, but basically the game details is packaged up by the model, sent to the strategy, it's used by the strategy, and then prices are sent back. And it's done 6 times really quickly. Okay, you can go maybe, just double checking here on the chat. Yes, all you need to do is make different numbers in some shape, way, or form. And this is meant to be a little bit like an FRC competition, because even a beginning team that can only put the ball in the low goal, they can be very valuable in an alliance. And the same here, someone who's choosing almost random numbers may or may not do well, and someone who's really thinking it through, they probably will be able to make some headway, but I don't think we'll take it too seriously, except that we're learning and we're seeing how everyone's strategies are. I'm really hoping to see a variety of strategies come through and see how everyone responds to the challenge of the game. So yeah, all you really need to do is make some numbers in some shape or form, but then you can apply your level of Java knowledge.
Will you have opportunity to throw any wrenches into the game, like throw in
I do.
You do. I thought I saw that in the code, some adjustment options.
Well, those adjustments, I didn't know what to call them, but that was from the initial. The adjustments are basically taking in the prices and doing some mathematics on them to determine how many customers. It's not really throwing a wrench, it's just doing the basic calculation. The biggest wrench, though, is the changing of the difficulty. So if we do happen to have the difficulty changed, then we're going to see well, there's still going to be a winner. It's just that all the players may end up losing money. That's all. And David is asserting that I'm going to completely mess up the game. I'm not sure what he means by that, but hopefully it will be okay. So the worst that can happen is we return a 50 as your price. So going back to our little slideshow for this evening, we went through calculating the average profit, for example, And we went through making some decisions if the profit is less than average. In this case, if the profit was less than 0. And now onto the robot simulator. Last time, the little robot only went backwards and forwards. And I'll show you a few things to do to get your robot moving all around in the simulator. Going over here, we can open a folder for that to happen. We'll go to the Drive Simulator 3. And remembering Control and P, that is the command palette. And we're going to simulate the robot code again. And I'll show the robot working. There are a few things you may notice that are different here. I put a game field on here. And when I put the robot in teleoperated mode, I can now use my arrow keys and drive it all around quite nicely. So
how did you put in the game field?
Exactly. I'm going to get to the game field in a moment, and I'll just show how I got the robot not going straight. So last time I had forgotten how I did it because I had done this before, but when I reviewed the game code, I found out what had happened. So down in the game code here for teleoperated drive, this variable was set to K right. So that indicates it was looking for an entirely different game controller. Now, the way I could overcome this, if I want to use this code, I'll just save the file here and I'll run the simulation again. And now I know it's looking for the right-hand controller. Okay, so when I put it into teleoperated mode, now my arrow keys, only the forward and backward ones are working because there's no second game controller. So to overcome that, I'll just put keyboard 1 down into here. And I forget which one is that, somewhere here. Okay, so that's looking like H and K are my left and right. If I put it back into teleoperated mode, oh, it doesn't like those, does it? So that's not my right controller. That is joystick 1, though. So for some reason, that's not working as I had hoped. I may be able to try putting joystick 0 down into there. Oh, it's still working there, but it's not accepting any other inputs. How about keyboard 2? Oh, and since I put keyboard 2 there, it unassigned it from here. So essentially, it's expecting another game controller. I guess I can't get it working as I had hoped. And this is the default code. I'm not sure why they put it that way, but I'm just going to put it back to how I had it working and expect the input from the left-hand controller, whatever that is. That's the controller 0. So saving this and putting the simulation back on, now I should be able to see the field come up, and my 4 arrow keys, they work quite nicely if I put keyboard 2 down into joystick 0. There it is, and put it in teleoperated mode. There we are, driving around again. So if anyone figures out how to get that right-hand controller working, I'm sure there's something simple to do. Anyway, this is one way to get your robot simulation working. Now, there was a question about the field. We can go to find a link to download things for the field on the internet here. Let's go to First Robotics Competition Control System and the simulation. And let's see. There are several pages to the simulation here. And we will look for the one that has to do with the game field. It's taking us through all the steps that I was just discussing here. Oh, maybe I'm just skipping over it. It didn't have the picture, did it? Changing view settings. No, application data. Somewhere in here, it should show a game field. Here we are, the field 2D widget should be it. There it is. Now, in this page here, it's called viewing, or what is it, the field 2D widget. And you'll see that under robot simulation, there is a place to change the field setting. And right here, you can retrieve the latest field image from here. When I click on there, I get a GitHub repository with several years of robot fields available. So for example, there's the 2020 field. There's the 2018 field. So if I save this, there's the 2018 field, just download it here. Now I could go and change that in my robot simulation. I've got several robot simulations open right now. Let's just close them. And here's one of them. Is it still working? Yes, it's still working, but I want to change it to the 2018 field. So right here, and if I right click, I can go to the field and choose an image. And my downloads, it should be there. And get the most recently modified ones, or is that where it saved it? Maybe it's under pictures. Oh, don't know where I saved that. So I'll manually put it into pictures here. Okay. There it is. And now I have the 2020 field in there. I should be able to, there it is. And now the 2020 field has been loaded. Sorry, is that the 2020? Anyway, it's a field. So let's try.
That's the 2018 field.
Oh yeah, 2018, sorry. Thinking and, or speaking and modifying a computer at the same time doesn't always work. Okay, so there's our field, and I change the image, right click, and go to the field and choose an image. And the downloads are on this site here, which is linked from the field 2D widget. So those are a few of the things that I had wanted to show just a little bit better use of the robot simulator. The autonomous now, how can we make the robot do certain things in autonomous? I'm going to show the code again. And that's the teleop. I did some modification of the autonomous. It turns out that these are coordinates. This is saying, let's start at 0, 0, which is the bottom left. And it's set up just like your XY axes in a classroom, and there's some kind of units. So I played around with the units. I told the robot to go to X equals 14 and Y equals 2, and then go back to 3, 5. And I can put a few more of those in there. I can put a whole list of translations. And then finally, we want to put it at 8, 8. That's the final coordinates. So all I did was take the sample code that came here, and I added a few new translations in there. And I used the tutorial here to do that.
That's not like how auto works in an actual match, right? Like,
well,
you won't be able to get coordinates in an actual game. Right?
No, you might have to do some calibration. So it might end up being 14 meters, or you have to do some kind of proportional kind of calculation. So you may try this on a real robot and see, when I put 14, it actually went 3 meters. So I work accordingly. So if you carefully characterize your robot, you can probably get that to be exactly in meters. And when they define this robot in the robot code, there are some variables that they put in here in the drivetrain, for example, that can be characterized very carefully to try to set it up as close as possible. So all of these variables here are meant to be characterized with your own robot, and you could get it close enough to meters. So that's some work to try with some trial and error and some reading and research. But if all goes well, if I put it into autonomous, it's going to put it to its default place, go to 14.2, turn around. I don't know why I did such a stylish turnaround. And it finally ends up at 8,8, which I'm estimating to be 8 meters over and 8 meters up. But that's just my guess. And that's a little bit about autonomous and something for us to try. Let's see once the season starts, if we can get some of our robots doing this little choreography and seeing how it looks in real life. Okay, and one final thing for this evening, my actual topic on the schedule had been to look at how hardware corresponds with your code. So just a few comments about that before we stop. In our robot simulator, this little slideshow is now showing this K left hand. I changed this from K right to K left to get it working with just the 4 arrow keys using keyboard 2. Displaying a custom field, we looked at that. And there's a link to where you can get the custom field images right there in the slideshow. And there's the example. And then the robot simulator, there's the starting point. There are some waypoints, like you're using a GPS, and there's the endpoint to get some more complex patterns of behavior. And if you carefully select some of these with geography in mind, then you can do some complex navigation around the field. Well, that is my theory, and it's only a theory until we see it working on a real robot. All right, so linking code to hardware, each device on your robot will have some kind of link to some code. And one of the things that we had to keep track of in my team was, when were we using a CAN bus motor controller with those little yellow and green wires? And when were we using a regular PWM controller? They have some tiny red, white, and black wires that come out to connect to the Roborio. They're not shown in this picture. So the code for importing just a regular sort of controller is like this. This is not a Spark, it's actually a Victor. So we would actually put a Victor, something like PWM Victor here. But the code for this one can only be activated if you install some special drivers from Cross the Road Electronics, in the case of this motor driver. That's just an issue you need to be aware of. If your team has these controllers, you have to do some extra configuration of your VS Code to get them working. And we'll be very happy to support that during the actual build season. Okay, so that's one way that where each device, though, is going to be imported as an item. And once again, that's not a Spark, it's a Victor. And then we declare a new instance of that object. And this here, K motor port, is a number between 0 and 9 for the Roborio. Those are the channels available on the Roborio. And that will make that motor connect to the logic in your program. Okay, a pneumatic system is very handy in your robot. It's not necessary, but it's very handy in certain applications in certain years. There's a pneumatic cylinder. It pushes open and closed to move parts of your robot, and it can do so fairly quickly. And there's an air tank and so on. And right here is the solenoid. Each of these solenoids has a channel. If it's a single solenoid, it has 1 number in the channel. And if it's a double solenoid, it has 2. So you have to know from your team hardware people which one it is. So here's how we initiate a single solenoid, and there's how you initiate a double solenoid, and the channels are there. Each of those numbers corresponds to a physical channel where you plug in red and black wires to go to your pneumatic control module, which is not shown there. So the point is, any of these hardware systems you need to look up. The way I did this, I looked on the website, the FRC website, and looked up the pneumatic system, and then found how to get that code. So for example, oh, there's some pneumatics code. There's a pneumatic control module, and there's a pneumatic solenoid plugged into channel 0, for example. Each of these things can be looked up on the control system website here. For example, where's some hardware? It's probably under hardware component overview. They talk about the hardware components. There's the pneumatic control model, voltage model, sorry. And there's the pneumatic control module. And then as you go down through here, you'll find actuators and sensors. The actuators, here are some of them pneumatic cylinders. And they show how to hook these things up. And then they show some links to the code. What I wanted to just mention tonight is that's what you do when you have different components getting included in your robot. You need to go through the process of finding the code that makes those components work. My final few examples here were some other devices. You can do a similar sort of process of looking each of these up on the control system. So I will leave that to you. And I'm just sort of getting this out there as you're preparing for the build season, and you'll need to know the process of going on to the FRC website and then researching various components and finding out how they will connect to the code. And each of these components tends to have some notes and some sample code. And to back all of that up, you'll find that in a visual code when you make a project and you want to make an example. You can find an example of almost anything here. There's the solenoids example. There's an encoder, and so on and so on. There's the gyro was up there, and there's sample code for each of those. All right, I think that kind of brings us to the end. Very happy to answer any other questions that may have come up.
You want to actually talk about like the process of like importing a motor, like the vendor depth thing?
So you would
I feel like that's going to be like very important for the build season.
Sure. I think what I could do is just give a little sample of the import of the motor from my previous team, just to show how that kind of works. There may be a change to it this season. So just going back here to...
You're not sharing your screen.
Oh, sorry, I unshared. I'll just...
Motor called?
Oh, pardon?
What's the new motor that got approved last year called? Is that?
I remember hearing about that, and then we never got to use it because things are kind of locked down. Isn't it something like a Neo motor? And going to our GitLab here. FRC 2021B, that was our repository, and our competition robot, and main. Oh, that was definitely not it. Oh, that's because it should be robot.java. There we are. Okay, now you can see our team had talons and victors, and they were .can. They were on the CAN bus. We've ended up using the CAN bus because we had more motors and items to control than could be fit onto the slots of the Roborio. So we declare a particular import for the Talon and the Victor, and you'll notice CTRE here, we had to download the libraries for that and install them in VS Code, and that'll be a topic for a future session, how to do some custom library installs. If you just have the standard Victors and Talons that don't use the CAN bus, they just have the regular PWM hookups, then you don't need that special extra step. But in our case, we had those motors imported, and then we declared an instance of each of the motors on our robot. You can see we have 4 drive motors on channels 1, 2, 3, and 4 for right motors and left motors. And then we had 2 shooter motors. Our shooter had a double motor with a gear, 2 motors hitting 1 gear. And then finally, we had a collector, which was taking in the balls from the floor. And so there's the motors there. Now, when we're putting the motors together, we put them into these little motor groups here, the left side group and the right side group, and the differential drive is a collection of the right and left groups together. In future sessions, surely we'll have time to go over that a little bit more. Just for an example though, a very simple code we're using for the shooter, for example, we just, if button 3 was pressed, then we set shooters to 100%. And else we set them to 0 with some extra notes for the collector. And that's how we basically drive the motors and connect them to the getting raw button. One is true and the other button is false. Then we set the collector to full speed ahead. Otherwise, the collector is at -3, for example, an example. There we are. We will definitely have some time to go over more of that. And we're gradually exploring the various features of the Java for FRC as we go. And hopefully by the early part of the build season, we'll be able to do a lot of things based on what we talked about here. So it's very nice to see everyone this evening. Please feel most welcome to sign up for the coding co-operation. The game manual is here and the registration link is also there. And put that into the chat one more time just in case. So you can sign up, and very happy to troubleshoot some of your code if you want to send it in. Yes, and I think David had a good point. You don't usually use coordinates. You might have to use some other calculations. You can use encoders to find out how far each of the right and left wheels have gone. And there we are. So yes, and encoders, we'll definitely have some time to look at how those work as well. So we'll look at how to hook them up to our code and see how they can interact with our motors, for example. We used encoders a lot to get very precise angles on our arms and for precise travel distances on the floor. And we had never used that trajectory system as was shown there. So that's an interesting thing to try out.
I have a question.
Sure.
Can FRC robot can FRC robots use PlayStation controllers, or is it only like Xbox controllers?
As far as I know, you can. We had Xbox controllers, but I think a few of our students brought in some PlayStation controllers. I wonder if there is a.
Because I'm looking to get just a tiny robot, one of the just one of the small ones, just to play around with. And but I do not really have any Xbox controllers at my house. I just have PlayStation controllers. So I'm just wondering if it still works.
I'm not sure. And when I looked it up, it just directed me to this site that says Xbox controller. And maybe this team is discussing online. I was just looking online there, and there was a team discussing doing some extra programming to translate between that controller's communication and what the game expects. And there's someone who created a class in which you enclose that controller to get it working. So it's not a simple plug and play kind of thing. You have to do a little bit of adjustment. Just as an example, I will just share the screen one more time here. Whoa, too many windows open. There it is. So this was a discussion I just found with a little bit of Google search, and someone wrote a little class in which they enclose their controller. So I think you'd probably get it working, but you have to do a little bit of research and working with it to make it all right. So lots of teams out there are there and ready to help, I'm sure. So with that, I hope everyone has a wonderful evening, and please feel most welcome to continue your correspondence, and we'll hope to see you all very soon.
Thank you.
Thank you.
Thanks, William. Good night.
Have a good night.
Have a great night.
Have a great night.
Bye.
Bye.